Okay, friends, we have already seen bus participation factor. Now we'll move on to branch participation factor. Branch participation factor. The relative participation of branch J in mode I is given by the participation factor Pji equals delta Q loss for branch J divided by maximum delta Q loss for all branches. So we are interested in a particular branch where the branch is connected between two buses. One of the buses can be considered as a sending end bus and the other bus can be can be considered as a receiving end bus because the power flows in one direction. So for that branch, how that branch reactive power flow responds to any incremental reactive load in the system. It can be in some other bus also. The change in reactive power happens at some other bus. Because of that, all the branch power flows are changed. Reactive power flows are changed. Accordingly, the reactive power loss is also changed because the current is increased. Active power flow is also changed, so current is increased. So the I squared X loss, I squared X line loss is also changed. Now, how this is different for different lines? This reactive power loss is different for different lines. This is because if any of the buses have incremental reactive load change, then the reactive power support, the corresponding reactive power support should come from some other bus, right? And we have many buses. So some buses will contribute more to the reactive power support and some other buses will contribute less to the reactive power support. Now, the bus that contributes more to the reactive power support, the line connected to those buses will carry more reactive power, right? So accordingly, the reactive power losses will also differ. So basically, to find the reactive power loss, what we need is this is incremental reactive power loss, right? Incremental reactive power loss, change in branch reactive loss. If this has to be calculated, this can be calculated with the angle and voltage variations for both the sending end and receiving end, right? So if we are considering the branch AB, if we know the complex voltage of bus A, VA angle theta A, and the complex voltage of bus B, VB angle theta B, then we can find the reactive power, the incremental reactive power flow through the branch AB, right? In response to some incremental load in the system that can be somewhere else. Okay, so this is what we need. So as this is incremental or deviation in voltage and deviation in angle, we are representing it by delta. So we need delta VA, delta theta A, delta VB, delta theta B for a change in reactive load in the system. Somewhere some delta Q has happened. Because of that, these two things have changed. Because of this, the reactive flow, Q flow, has changed. That is delta Q flow has changed. Because of this, delta Q loss has changed. From this, we can find the participation factor, branch participation factor. Now to find delta theta and delta V, delta theta can be in different modes. So we are interested in the ith mode. Okay, so for delta V also we are interested in the ith mode. Now delta Vi can be written as 1 by lambda I into delta Qi in the ith mode VQ sensitivity. Right, the corresponding vector of bus voltage variation. Now the corresponding vector of bus voltage angle variation, that is delta theta I, which is equal to minus j p theta inverse j pv into delta vi. So from here, these are the Jacobian elements which relate active power and voltage angle and active power and voltage jpv and jp theta. Right. So based on these Jacobian elements, we can find the V theta sensitivity here. Here we have delta V and delta theta, right? Delta V and delta theta. Okay. So if we know delta V and delta theta from the eigenvalue and corresponding right and left eigenvectors, we can find delta VA, delta theta A, delta VB, delta theta B. So then we can find the Q flow and delta Q loss and then the participation factor, branch participation factor. So what it means is the relative participation of branch J here again, the relative participation of branch J in mode I, right? In mode I is given by this participation factor. Okay, so branch participation factors indicate for each mode which branches consume the most reactive power in response to an incremental change in reactive load. Right, reactive load. So branches with high participations are either weak links or are heavily loaded. Right, that means the branch itself is weak. Now, this is useful for identifying remedial measures to alleviate voltage stability problems and for contingency selection. What is contingency selection? You might have heard of N-1 contingency analysis. If it is for buses or if it is for generators, we remove one source at a time, right? So selection of that source is important. Like that, if you are removing one branch, selection of that branch is important. So which all branches are more vulnerable to reactive losses with respect to incremental reactive power in the system, that could be identified by the participation factor, branch participation factor. So it will help the contingency selection. Now coming to generator participation factor. Now I am moving on to generator participation factor. Generator participation factor. Here, voltage and angle are determined at each machine terminal for a given reactive power variation in a system. So in the previous section also, in the branch participation factor also, we were trying to find the response of different branches to the incremental reactive power load in the system. Similar to that, here for the incremental reactive load in the system, how the machines are responding. Machines are responding in the sense how the voltage and angle are changed. V angle del is changed with respect to change in reactive power in the system. So this is used to compute the change in reactive power output for each machine. So if the system reactive load has changed, if the system reactive power load is changed, then accordingly different machines will, this reactive power is extracted from different machines, right? So some machines contribute more and some machines contribute less. So this is what is studied here. The relative participation of machine M in mode I is given by PMI equals delta QM for machine M divided by maximum delta Q for all machines. So if this ratio is more, means this machine M is contributing more, right? Because this is like the maximum delta Q for all the machines is in the denominator, right? So this is the participation. If this is more, if this ratio is more, magnitude of this ratio is more, that means the mth machine is contributing more. Or this indicates which generators supply the most reactive power in response to an incremental change in the system reactive loading. So this can be used to properly distribute the reactive power reserves. Because if there is a random increase in reactive power, it should be supported from the reactive power reserves. And many generators would contribute to the reactive power reserves. And in what proportion each generator should contribute to the reactive power reserve, that can be determined using generator participation factor. So that's all with participation factors. Now we will move on to shortest distance to instability in the next lecture. Thank you.